जी So now, I would like to invite the person who has given this wonderful idea about the lecture series on robotics, our respected HOD ma'am of EC department and convener of this program, Dr. Jyoti Jain ma'am. Please encourage all of us.
Thank you, Uday sir. Good afternoon, everybody. On behalf of EC department, I welcome you all to the inaugural session of lecture series on robotics in association with IISER Bhopal under PMRF scheme. Actually, EC department has planned to develop a robotics center of excellence at SIRT in year 2022. Aim of this center of excellence is to facilitate students to experience practical exposure in latest electronics and communication technologies so that students will be able to apply this knowledge for the benefit of the society, as well as they will be able to resolve real life problems. We have planned various activities under this banner. This lecture series is first activity in that direction. Later on, we will conduct one national level robotic competition, one poster presentation on future robotics, one drone competition, and many more. Happy to share that some of our students are already working for the development of automation helpful for mankind. On behalf of EC department, I am thankful to Dr. Ram Kumar Mishra sir from IISER for this great initiative of helping nearby institutions. Thank you, sir. Thank you very much. Thanks to Engineer Manav Mishra for accepting our proposal of conducting the lecture series on robotics. I would like to communicate to the students that participating in the lecture series that a participation certificate will be issued to the students who attend all the lectures and participate in the quiz afterwards. Thanks to our management and our director, sir, Dr. Rajesh Shrivastava, for giving their support for organizing this event. Thank you all and welcome you all in this event.
Thank you so much, ma'am, for your kind words and guidance. Now, I would like to invite Dr. Ram Kumar Mishra, sir, who is Dean and Academic Affairs, IISER Bhopal, who provide us this great opportunity for our student in this very relevant field, robotics. So, please, Dr. Mishra, sir, please, I'm over to you, sir.
Welcome.
Thank you, Dr. Uday. Thank you, ma'am. I hope you can hear me.
Yes,
sir.
Yeah. Thank you all for this wonderful session and the initiative which you have started. And thank you for entertaining our request so that the PMRF students which we have at our institute, they can be engaged in these activities at local colleges and institutes. And just to inform you that this PMRF scheme is very prestigious scheme for a research scholar to take their research to a level where they are doing cutting edge research and competing with world. And I'm very happy to share that Mano is one of those fellows who have been recently selected in this PMRF scheme. And through this scheme, we would like to engage with different institutes around and maybe in a more informal manner, like this is a very unique twist which has been given and Mano has agreed to give the lectures over there. However, maybe it is that we can engage in other teaching activities which are happening at your institute. And although I'm not in the field of robotics, my expertise lies in biological sciences, but when Dr. Uday asked me to say something, I don't know what to say about robotics, just that it is, we all see the use of that in current time, as well as we know that this is going to be the area which will be explored even further. And as you suggested, your students are working towards generating things which is going to help mankind, and robotics is definitely going to help us in that direction. And when I think about robotics, there are so many things, but I think what I can relate is that my kid is the one who actually plays with these Rubik's Cube. I think everybody has seen Rubik's Cube at their home. And I was just looking online, while human can solve a Rubik's Cube in 4 seconds, the robotics helps it solve by in 0.38 seconds. So this is the speed, this is the enhancement which robotics is doing in our day-to-day lifestyle. And I'm sure, I'm not exactly sure what Manav has planned to speak over these lectures in this series, but definitely whatever he has planned will be benefiting the student and those who are participating in this lecture series. So I really hope that it will be a worthwhile exercise, and people associated will be benefited. And we also look forward to engaging in more comprehensive manner, especially these PMRF fellow in more comprehensive manner with the activities which are going on in your institute. So with these, I would like to thank and would say that you may go ahead and start whatever is the plan.
Thank you, sir. Thank you, sir. Definitely, our students will get benefited with this scheme, and surely in this year 2022, we are planning many more activities. So
yes.
Definitely,
I would actually like to visit the institute, and we can have a more formal discussion and say that we can actually formulate things that okay, how more students can be engaged. Like
yes,
Mano is one of the person whom you found, and he is contributing. We would
yes.
like most of our students to contribute to activities which goes on in schools and colleges nearby.
Thank you, sir. Even we can visit your institute for the talk. We will visit.
Sure. This is very much appreciated, and we feel that the colleges and institutes which are around us, they can actually come and see how they can engage and how we can engage in a mutually beneficiary events or things, right? So we look forward to all that.
Thank you, sir. Thanks.
Sure, ma'am. Thank you very much. Thank you.
So thank you so much, sir, for your kind words. And now I request all the participants from SIRT to make use of these six lectures to your best of their abilities. And I thank you all the participants who showing interest in such kind of lecture series. So we will start the session by 2 o'clock. We have 10 minutes.
Before that, I think Mano Mishra ji is also there. So welcome you, Mano.
Yes, ma'am.
Thank you, sir. Thank you, ma'am.
Okay, so can you start right now? Why to wait?
Okay, sure.
Can you start right now?
Yes, okay.
Okay, so let us start the session. And I would like to share that we are going to conduct 6 lectures in continuation with Manav Mishra ji. He is actually a PhD scholar at IISER Bhopal, and he has given his consent to conduct this series. And for the students, I think you should attend all the lectures and get all the benefits. And as I communicated to the Manav sir, that he will discuss more practical situations rather than theoretical concept. Okay, so let us start now.
Sure.
Okay, thank you. I'll share my screen. Okay, so is my screen visible to you? Am I audible to all?
Yes, it is.
Okay, fine. Okay, good afternoon, everyone. I welcome you all to this lecture series on intelligent robotics. So as per plan, I'll be taking out 6 lectures, which will be sort of an introductory course to robotics. And I hope I can make you understand and appreciate what are the benefits and usage of robotics that we have in today's world with the current technology. And hopefully you also enjoy learning along the way. So let's start. Okay. Right. So I'll just give a 2-minute introduction about me. I think it has already been established by Dr. Ram and Uday sir. So I am a PhD student in the electrical engineering and computer science department at IISER Bhopal. So I joined as a PhD student in August 2020. I'm currently in my 4th semester, and this lecture series that I'm conducting is basically a part of my fellowship, which is the Prime Minister Research Fellowship Grant. And each semester I have to carry out certain teaching duties to be eligible for this fellowship. And I work at IISER Bhopal, and I'm a part of Moon Lab at IISER Bhopal. You can probably search it later on. So that's all about me. Sorry, it's a bit slow, the slide changing, it's lagging a bit.
No issue, no issue.
Okay. Okay, why is it not loading? Sorry, let me just check it out. So you all can hear me clearly, right?
Yes.
Yes, sir.
Okay.
Do you need some time?
No, I'm just trying to refresh it.
Okay.
How the limbs or the arms, how the limbs or the arms of a robot move with time, and this basically involves fine tuning the actuators, the controllers, and mainly it is focused towards the mechanical engineering aspect part of it. Second fundamental is something known as navigation. So navigation is basically the robot's ability to determine its own position in its frame of reference and then plan a path towards some goal location. So it's like a robot should have also have a navigation system, because if a robot is supposed to go from point A to point B, so first of all, it should have this much capability so it can localize itself. It should know its current positioning with respect to its frame of reference. And then it should know the uh, goal location, and accordingly it can plan a path towards it. So navigation is a very interesting domain where a lot of people are working it. So in order to navigate in its environment, the robot or any other mobile device, they require a representation, or you can which is a map of the environment. So navigation is the second fundamental. Third is the perception part. So perception is understood as a system that endows the robot with the ability to perceive, comprehend, and reason about the surrounding environment. So perception is necessary, right, to interact with the environment, to decide on the course of action and so on. So this perception is carried out by equipping robots with several sensors. Like for obstacle avoidance, you use stereo cameras or even LiDAR technologies and so on. So these all come under the part of perception. So these are the three fundamentals of robots that we have. So this I'll show some videos. So these are basically a part of the outdoor activities of Moon Lab, the lab which I'm working on, which I'm working in currently. So these are few outdoor activities which has been carried out at IIT Delhi. So I'll show you what work is being done. So this was carried out by my seniors. So you see what this robot was trying to do, what this drone was trying to do was basically it was following the ball. So because of perception, it was trying to locate its position with respect to the ball, how much distance it should maintain. And when we try to move the ball, it is actually trying to follow that. So this is one use of perception in robotics. Second, if you look at this, so these two are basically the same videos. This is from a human perspective. So you see a drone over here, and this is from the drone's camera. So what it is trying to do is the drone is trying to land in this region. It's known as autonomous landing. So this red region is where the drone is expected to land, and it is coming from this height. So see how it is measuring the velocity, the altitude, and how it is detecting the landing location and so on. And slowly you see it will land after some time. So these are some of the videos that I'm showing you, which working with drones. There are also several other different types of drones available. This is known as a quadrotor because it has 4 arms. There can be drones having 6 arms, or even there can be a fixed wing drone. There can be flapping wing drones and several other different drones available in the market. And yeah, just skip it. See, it has managed to land successfully, and this is from the camera of the drone. Okay, so moving on. Okay, so I have pulled out this image from a Medium article that I was reading yesterday night. So this is basically something known as the robotics chart. So robotics are of can be divided into 3 categories. One is the theoretical aspect of it. One is the simulation. Next is the experiment. So these are the 3 stages how the technology is developed. First, we come up with theories. Then we test these theories on simulations. And after testing it on simulations, after knowing that these are safe, we test it out on real robots and experiment it. So robotics basically comprises of different aspects. Robotics is made up of linear algebra, probability, control theory, optimization, calculus, and so on. And it has different use cases in perception, navigation, manipulation, and motion planning. So for this lecture series that I've planned out, so you don't need any prerequisite for control theory. You don't need optimization techniques. You don't need maybe some bit of probability, but yeah, a simple mathematical background is what I'm assuming as a prerequisite. And mostly I'll be focusing on this part of robotics, which is motion planning. So over the course of 6 lectures, my focus is mainly towards robotics motion planning. And in the last lecture, we I'll show some simulations for whatever robotic algorithms that we have that we'll discuss over the course of this series. And yeah. Any questions so far? Okay, I'm assuming there are no questions. I'm moving ahead. Okay, so classically, if you look at motion planning, okay, I'm now starting into motion planning. I'll just give a brief introduction of what motion planning is. So there's a classic problem known as the piano movers problem. So what the piano movers problem is that you have a piano in a room. You have to move the piano from point A to point B. So in order to move the piano, let's say a piano delivery guy is coming to your house for the first time. He doesn't know the location of the houses, the location of the objects in the house, right? So there are different obstacles. So one key point is they have to carve out a path to reach from point A to point B. So a valid path is basically something that doesn't pass through an obstacle. So if you look at this image over here, this gray areas represent the obstacles. So the planning part here involves we are trying to carve out a path in such a way that we have a smooth path towards the goal location. So this is an example of a valid path. This is an example of an invalid path. So this is something which we, sorry. Yeah, so this is something which we call as path planning in robotics. So how path planning is different from motion planning is that path planning is basically when you're trying to reach from point A to point B, the planning of a smooth and continuous curve to the goal location, which is something which comes under the domain of path planning. How motion planning is different is you need not have a continuous path, but you basically define your path as you go along. So this has more real use case scenarios, because for doing a complete path planning, you need to have a full idea of what the environment is. You need to know about the positioning of each obstacles, and if you have the complete information of the environment, only then you can do a path planning from point A to point B. Whereas in motion planning, you don't necessarily require to have a full information of the environment, but it's like as you go along, as you move along, you interact with different obstacles. You try out different combinations, and by that logic, you reach the end of to the end goal location. So this is basically what the piano movers problem is all about. So I'll try to categorize motion planning. There are 4 main categories in motion planning. One is navigation, the problem of finding a collision-free motion for the robot system from one configuration or one state to another. Navigation is basically you're trying to find what the piano mover problem was doing. Next set of problem in motion planning is something known as coverage. So coverage is basically the problem of passing a sensor over all points in the space. Coverage is basically you have an area, you have a bounded region. Your goal is to cover each and every region of that area. So where can you find the use cases? Let's say you're doing vacuum cleaning in your house. So in vacuum cleaning, area coverage is necessary. You need to cover each and every corner of the room. In let's say in your campus, you might have securities roaming around each and every part of the campus. So for them, area coverage is necessary. They need to monitor each and every point inside the campus. Or let's say even in military use, in defense use, when you're patrolling the borders, you need to cover each and every point with minimum time so that you are reducing the blind spot that is being left around. So this is basically the coverage problem. Next is something known as localization. Localization is basically the problem of using a map to interpret sensor data to determine the configuration of a robot. So it means the robot needs to look at the map around itself. So if I leave a robot in an environment, so by looking at different positioning of the obstacles and different data that it collects, it is able to localize itself in the environment. It can exactly say where it is in the environment and how the different obstacles are placed. This is the localization part. And there is something called as mapping. Mapping is basically the problem of exploring and finding an unknown environment. So you have an unknown environment, you have a robot, you're basically trying to like move as you move along the environment, you're trying to create a mental map of what different environments there is around us. So this is the mapping problem. So this localization and mapping are sort of they go hand in hand. It can be thought of as a chicken or an egg problem, because you can't say which is needed first. Do we need first localization, or do we need mapping for localization, or do we need localization for mapping? Because if you want to map an environment, you should know with 100% accuracy your current location. If you know your current location, only then you can make a map of the environment around you. But also it's like if you once you know the map, and only then you can localize. So sorry, if you know the map, if you want to know the map of the environment, then you need to know your localization with 100% accuracy. But it can also be true for the other way around. So if you don't know your current position, you can't do mapping. So this is something known as the SLAM problem, or the simultaneous localization and mapping problem. We won't go into this detail. We'll mostly focus on navigation and coverage part. But just to give an intuition, this is what these two are the regions. These two are the different types of motion planning that we'll be covering in the coming lectures. Right. Okay, so this I come to the last slide. I'll just introduce what is bug algorithm, and after that I'll stop. So this is something which is for lecture 2. I'll discuss what bug algorithms are in detail. So just to give an intuition, bug algorithm is basically a class of simple and intuitive problem known as a bug algorithm. It requires minimum mathematical background to implement and analyze navigation. So the simple task is you want to navigate a robot, a point robot, from a starting location to a goal location in an unknown environment. So this environment has obstacles around it. The goal is the robot should go from point A to point B without hitting the obstacles. So these bug algorithms are basically sensor based. The robot uses a contact sensor or an IR sensor to determine if it is touching the obstacle or if it is approaching the obstacle. These are the only sensor it has. We will mostly go with the assumption it has a contact sensor. If it touches the obstacle, it knows that it has the obstacle part. And the robot will have two different motion parameters. First is it is either moving in a straight line, and second is if at all it hits an obstacle, it should follow the boundary of the obstacle so that it can move around it and go to the goal location. So these simple algorithms guarantee whether the robot will arrive at the goal location if at all it is reachable. So these algorithms provide a guarantee, a theoretical guarantee, that if a goal location is reachable, the robot using these algorithms, we can reach the goal location. So this is something that we'll look in the next lecture. So this lecture was mainly supposed to be an introductory session. I wanted to basically introduce you to different aspects of robotics that are being used in today's time, and also to give you an introduction of what one should expect in the coming lectures. So my focus is